odd function, y equals x cubed is an odd function. Why do you think we call that an odd function?
Cubed.
Yes, because it's x cubed, but that's not the definition of an odd function. You could think of a graphical representation, and a graphical representation of an odd function would be x cubed. And if you had the shape of that cubic, we say that it is odd because it can be reflected around the origin. If you spin it 180 degrees, you get the same thing. That's what makes it odd. The mathematical notation for an odd function looks like this. There's an actual test that you must do in order to show that it's odd. And it is f of negative x produces negative f of x. That is the test that you do to show that something is odd. Now, we practiced this a little bit before. We're going to use this a couple more times throughout the year. Very important that you see this take roll and take place. Let's look at this first one. Notice that the exponent is 3 and the other exponent is 1. This tells you ahead of time that it's going to be odd. But we need to show that it's odd. So we're going to plug in a negative x. And when we plug in negative x, we get quantity negative x cubed minus 4 times negative x. Negative x cubed, will that produce a negative x cubed or a positive x cubed? This is a negative x cubed. And then I have minus negative 4x. Will that be plus 4x or minus 4x? Plus 4x. Is that the same as what we started with? It is not. Let us try factoring out a negative 1, and I get x cubed minus 4x. Is that the same as what I started with? Yes. Not the negative, but the x cubed minus 4x is the same as what I started with, right? Okay, so watch my notation here. So this is equal to, I have a negative sign, and then this x cubed minus 4x, that's the same as f of x. Do you notice what I've done there? I've stated that f of negative x is the same as negative f of x. Isn't that the rule that we were trying to show up here? You just did a proof. Because in a moment there, Alex was like, hey, I like that. That connects for me. It makes sense. I like that substitution. But then he heard proof, and his mind automatically went to negativity town, right? Turns out you actually like proofs, don't you? You do. Okay. Now, turns out that not only y equals x cubed is an odd function, there are many others. Y equals sine of x is also an odd function. You can't always tell just by looking at the exponent. Sometimes there are other characteristics about it, namely the graph. We're going to talk about an even function. Can somebody take a guess at an example of an even function? Y equals x squared is an even function. Notice the exponent is even. What makes it even is if we were to graph it, notice that it is symmetrical about the what? It's a letter of the alphabet towards the end. It's symmetrical about the y-axis. And the test for symmetry about the y-axis or an even function is this. F of negative x produces f of x. Okay, so this one right here, we have negative x squared plus 10, and the variable on it is an x to the 0 power. We don't write x to the 0 power because what is x to the 0 power? Anything to 0 power is 1. So you can see that these are actually both even powers. 2 and 0 are what we refer to as even powers. We're going to show that this one is even. We plug in a negative x, and we get negative parentheses, negative x squared plus 10. Is it going to be a negative x squared or a positive x squared? It is a negative x squared. And then it's a plus 10. Is that the same as what we started with? Yes. So I could write, instead of negative x squared plus 10, I can write f of x. Notice what we just did. We said f of negative x is f of x. You just did a proof. You showed that it was, in fact, even. Not too bad, right? Even and odd is now something that's really super important in mathematics. It does come up a little bit in trigonometry. We'll reference that. The main reason why I want you guys to see this is it does come up on the ACT as well. What do you think the average ACT score was for the juniors taking this class last year? Average ACT score for the mathematics for the juniors taking this class last year?
22.
27.3. That's pretty good, isn't it? Yeah. I would hope that this year our average ACT math score for juniors taking this class would bump up to 28 or higher. Okay, I think we can do it. We had multiple people in the 35s. Okay, high score is 36. I had sophomore one time take the ACT. I encourage sophomores to take it all the time. It's like all my kids will take it when they're sophomores as well, and then juniors. I had sophomore take it one time. I got a 36 on the math. So actually, most of the math you learn for the ACT is math from 7th, 8th, 9th, and 10th grade. Not a lot of it comes from when you're a junior. Some of the real kind of a little bit more challenging parts, but a lot of it comes when you're younger. So, okay, the last one, I'm going to switch the problem. I don't like this one. I'm going to switch it to f of x is equal to x to the 4th minus x squared plus x. So instead of a plus 1, I want you to write a plus x on the end. Okay? Everybody okay with that? All right, so we're going to plug in a negative x. F of negative x is equal to negative x quantity to the 4th power minus negative x squared plus a negative x. Will it be a positive x to the 4th or a negative x to the 4th? It will be a positive x to the 4th. Will it be a minus x squared or a positive x squared? It is a minus x squared. Is it a minus x or a plus x? Minus x. Is that the same as what I started with? It is not. And if we do factor out a negative, we get negative x to the 4th plus x squared plus x. Notice that's not the same as what we started with either, is it? So this is not odd. It is not even. It is neither. This one was even. This one was odd. You good? Okay, so you should be able to practice the even and odd and neither on your assignment. And then here we get to this part right here. This goes very, very well. I put this on here because when we kind of do the process, I know you guys have been given rules before and you graph the function. Now you're given the function, you have to graph the rules. When you go back and forth, studies show that this enhances your brain development. You actually understand this more deeply. That's important because people were getting these wrong before in the ACT, and I don't want you to get these wrong because you should get these right. You guys are all really smart. So the first thing I want to do is just identify the parent function. The parent function is x squared. Describe for me the transformation that's taking place here. Left 3 and up 1. So therefore the rule would be y is equal to x plus 3 quantity squared. That shifted it to the left 3 units. And then I add 1. What's the parent function for the next one? X cubed. Notice I have a horizontal shift to the right 2. So that will be an x minus 2 quantity cubed. What else is included in this transformation? Yeah, the negative, notice how it's flipped upside down? So we're going to stick that negative on the outside. Try number 3 on your own. should have negative absolute value of x plus 3. Notice the plus 3 is on the outside because it is a vertical shift. Plus 3 is on the outside because it is a vertical shift. We're okay with that? All right, number 4 is the one that people get wrong most often. I would say over 50% of classes getting number 4 wrong. You try it on your own. Works a lot better if you try it on your own than I show you as opposed to me just doing it. If the teacher does all the problems, it looks easy.
Yeah.
Which one is it?
Fourth down.
You're going here?
Yeah.
Anybody else want to take a shot?
Yeah, second one? Yeah, second.
No, it's.
Anybody else want to take a shot?
I think it's
It's just negative x plus 4.
It's. It's the
This
third
one?
It's the third one.
You're saying the third one?
It's the third one.
Okay, let's talk about it. There's obviously confusion out there. Let's make sure we understand. I want to be clear about this. This is very, very important. Okay, this is where like you actually try to build multiple days so that your class can learn something. This is where you're hopefully going to really sink it in. Okay, the square root of x minus 4 looks like that, right? So you know it's not this one. This, the negative is on the outside, so it creates what kind of a flip? A vertical flip. So that one looks like that. So this is not it. Okay? This one, okay, is a horizontal flip. Heads off to the left. But this is the same thing as the square root of negative times x plus 4. So notice that in this situation, the horizontal shift is left 4 units. This graph right there is this one. So this is not it. These 4 are all the same, aren't they? All 3 of these have a negative x and they have a positive 4, don't they? These are all the same right here. And so I don't care how you write it. But when I look at the red one, here's what I think to myself. I say shifted right 4. So I go x minus 4. And then I say reflected back that way horizontally. So I put a negative there. Now you can leave it like that, or you can write as a square root of 4 minus x. I don't care, but that's what it is. Now, here's the piece, and this is the beauty of it. And this is where you know you've kind of started to achieve more of an elite level being a mathematician, is when you know how to check your answer. And so I want to see that this is for sure my answer. How do I know that the answer is not square root of negative 4 minus x? Because let's be honest, raise your hand if you put negative 4 minus x. Raise your hand if you have that. Okay, we had a few people write that. Here's how we know that this is not accurate. You know that it goes through the coordinate of 4, 0. Agreed? Well, just try plugging in 4. If you do, you should get 0, right? But if you plug in 4, you get square root of negative 8. You don't get 0, do you? But if you plug in 4, 0 to this guy, you sure do get 4, 0. So use the points that you have. See if the rule is satisfied or not. Okay, 2 more. I got this guy. This is a reciprocal function, which is 1 over x. Notice that the shift is to the right 3 units. So I have 1 over x minus 3. And then I have a vertical shift of 1. Since the vertical shift is 1 on the outside, I have a plus 1. Do you know the parent function for the last one? It is not 1 over x squared, but thank you for offering your expertise. You were brave. Yes?
Third root of x. Is that
Third root of x looks like this.
Third root of x squared.
Very good. This situation here is the graph of x to the 2/3, otherwise known as the cubed root of x squared. The parent function looks like this. Remember, it is kind of like a cube root function, but it makes both of them positive. So notice how the transformation has been 4 units to the right and flipped upside down. So this is y is equal to x minus 4 raised to the 2/3 power. That's what the parent function to the right 4 units, and then the negative flips it upside down. That's our result. Not too bad. Not too bad. Congratulations, you guys! You're about halfway done with 3 college credits in mathematics. What does that save you guys? Like $2,000?
Probably.
How about I just want a 5% cut? Okay. What's 5% of 2,000?
It's a number.
Maybe we shouldn't get credit.
It's
$100.
$100. It's $100.
It's $100, right? Because 10% is 200. So we're doing half of that. Good job. All right, Ben gets credit. All right, you're leaving me hanging here. I can't believe it. Okay. All right. So how about I just collect 5%? 5% tip. That's pretty small in the business, isn't it? If I'm a waitress, I want at least like 15 or 20%. I'll just take 5%. Tell you what, I don't even want 5%. Just give me 1%. $20 bill. All right, I'll do it for free. You convinced me. You guys are too nice. I'll just do it for free.